In this video, we're going to talk about how to simplify algebraic expressions by combining like terms. So remember, in the last lesson, we started talking about simplifying expressions. We were using the distributive property to simplify expressions, and now in this lesson, we're going to talk about how to use combining like terms. So what is combining like terms? It's an idea that allows us to put together terms that have the same variable. And it's very important to remember that to combine the terms, they have to be exactly the same. So that means it has to be the same variable raised to the same exponent. It also allows us to put together constant terms. So let's look at this chart and look at our column with unlike terms and see why they cannot be combined. So for example, we have 2x and 2. 2x is a variable term and 2 is a constant term. So these two terms cannot be combined. 3x is an x term and 5y is a y term, so they cannot be combined because they're two different variables. 2x and 3x squared cannot be combined because although they both contain an x, one contains an x squared. So remember, they have to have the same exponent and be the same variable in order for them to combine. 8y and 5y will not combine because one is a variable term and one is a constant term. So let's look at our column with all of our like terms. 2x and 19x are like terms, and when they combine, we combine the coefficients. So 2 and 19 will give me 21x. 3 and 5 are both constant terms, so when they combine, I get 8. 12x squared and 3x squared will combine, and we will get 15x squared. 8xy and 5xy will combine, and we get 13xy. So let's try simplifying this expression by combining like terms. So when I go through and I try to identify the sets of like terms, I like to work from left to right. So I'm going to start off with this 8x term, and then I'm going to scan my problem and look for any other terms that have an x. So I notice this 12x term. So I'm going to write these two terms together because I know that they are like terms. Now my next term is my 2y. So I have no other terms with a y in them, so I'm just going to leave that 2y by itself. Now I have this 9 term, which is a constant term, and if I scan my problem, I find that this minus 3 is another constant term. It's very important to remember that when you're rewriting this problem, the sign that is in front of the term in the original problem must stay with it. So this 9 is going to be a plus 9, but that minus has to stay with the 3. So let's now group these terms together. So we have 8x plus 12x. I'm going to combine those coefficients, and that's going to give me 20x. 2y has nothing to combine with, so that gives me plus 2y. 9 minus 3 will combine, and that gives me 6. So this is now my simplified expression, which you can see is a lot simpler than all of the terms I had in my original problem. So now let's simplify this expression by combining like terms. So we have 16x plus 12y squared plus 12x plus 4y. So I'm going to start off with 16x, and I'm going to look for any other terms that have an x in them. So 16x will combine with my 12x term. Now I have my 12y squared, and I'm going to look for any other y squared terms. So here's where you have to be careful. This 4y has a y in it, but it's not a y squared. So we can only leave that 12y squared by itself. Same thing with 4y, there's no other y terms, so we have to just leave 4y by itself. So let's group our like terms, which in this case is only the 16x and the 12x. And then when we combine them, we get 28x. And then we just bring down the 12y squared and the 4. So let's try simplifying this expression by combining our like terms. So notice my first term is a 3k squared. So I'm going to go through and look for another k squared term, which I do have in my problem. So I'm going to write 3k squared minus k squared. My next term is now this 8.2. So I'm going to write plus 8.2, And since that is a constant term, I'm going to look for any other constants. And here I have a 12.6. So I'm going to combine these terms together. So I have 3k squared minus k squared. Remember that if you have a variable and there's no number written in front of it, that is an implied 1. So that's basically like there's a 1 there in front of that k squared. So this is going to be 3k squared minus 1k squared, which gives me 2k squared. Then I have 8.2 plus 12.6, so that is going to give me 20.8. And that is now my simplified expression. Now let's try simplifying 5ac plus 2b plus 7ac minus 5a minus b. So now we're going to go through and identify this first term and look for any like terms. Like terms have to have the same exact variables. So I can only combine this with this term that has an a and a c in it. It cannot combine with this a term because that does not have the exact same variables. So 5ac will combine with 7ac. Now my next term I have is my 2b. So I have plus 2b. I'm going to scan my problem and look for any other b terms, which I can. I have this minus b. And then I have this minus 5a at the end. So now I'm going to group my terms. So I have 5ac plus 7ac. When I combine them, I get 12ac. I have 2b minus b. Remember that b basically has a 1 in front of it. So 2b minus 1b will be 1b, which you can write as 1b or you can just write b. And then I have this minus 5a at the end. So that is now my simplified expression. So remember that you can combine like terms to simplify expressions. That means that terms with the same variable raised to the same exponent can combine and constant terms can combine.